Hello everyone. In the previous video, we delved into the intricacies of interfacing virtual communication ports between Walkwi and Flojoy. Today, we're diving deeper into Flojoy, focusing solely on simulating digital signals and implementing digital signal processing techniques to filter out specific frequencies. The objective of today's exercise is to simulate the filtering of an analog signal using a digital Finite Impulse Response or FIR filter to extract a 25 Hz frequency component from various oscillators. Let's get started. First, let's set up our signal generation. We'll configure the signal generator to produce multiple oscillators within the frequency range of 10 Hz to 35 Hz. One oscillator will generate our target frequency of 25 Hz. We'll set the sample rate to 100 samples per second and generate an array of samples with a length of 400 samples. There we go. I've set the frequencies of each of the oscillators. We will be adding the ADD block and connecting all of the oscillators each into it. There we go. For the last oscillator, we will be connecting a visualization block, which in here is called a line block. With our signal generated, it's time to configure the FIR filter. Using knowledge from our digital signal processing lecture, we'll choose an appropriate window method for the FIR filter and determine the low and high cutoff frequencies to create a bandpass filter. Let's adjust the filter order and coefficients accordingly. See, we will use a bandpass method, and we use a cutoff of 23, high of 28, 80 taps. Now let's visualize the frequency spectrum. We'll add an FFT module to the project and connect the output of the FIR filter to the input of the FFT module. The FFT module is to process the input signal. We'll add a chart module to display the frequency spectrum. FIR goes to here, so before the FFT, after FFT. With our setup complete, let's run the simulation and analyze the results. We'll observe the time domain signal before and after filtering and analyze the frequency spectrum displayed on the chart. Our goal is to identify the peak corresponding to the 25 Hz frequency after filtering. In this approach, we generated an array of 400 samples, as I said, with a sample rate of 100 using these basic oscillator nodes, each contributing a distinct sine wave with frequencies ranging from 10 Hz to 35 Hz. These signals were combined into a single waveform through the ADD block. To isolate the 25 Hz sine wave, we employed the FIR node to filter out all frequencies except 25 Hz. We chose a bandpass filter, like I said, with a high cutoff frequency of 28 Hz and a low cutoff of 23 Hz. Applying the hand windowing to sharpen the cutoff and retain only the desired frequency in the output. Finally, the filtered output from the FIR node was visualized using the line blocks, generating waveforms similar to that of our target oscillator. 2 FFT nodes were incorporated to visualize the frequency content before and after passing through the FIR filter. And there you have it. By simulating digital signals and implementing digital signal processing techniques with Flojoy, we've successfully filtered out the 25 Hz frequency component from various oscillators. I hope this tutorial was helpful. Thank you for watching.